Today, we're going to have a brief demonstration of how graph databases and graph algorithms can help you improve your customer experience. We're going to do that using a graph with a very simple data model where in the center here you see a customer, some demographic information such as where they live, their email address, etc., as well as the orders and returns and products that those customers have interacted with. And we're going to look at three common tasks for improving the customer experience. We'll start with entity resolution. Entity resolution is all about making sure that we have each customer represented exactly once in our data instead of having multiple versions of the customer from different systems or with slight different names or different email addresses. We want to get a clear picture of everything that customer has done. So how do graphs help us perform entity resolution? Well, we could start by looking at, for example, some PII, some identifying information that is shared by multiple customers. Now we'll start off here by flagging anything with more than 10 customers associated with it as being an outlier. That seems like it's probably something we need to take a specific look at individually and have somebody identify why we have that problem. So we'll flag those so that we can move on and ignore those for the rest of our processing while somebody rectifies those. So here you can see an example. We have some PII or some identifying information shared by more than 10 customers. So as we move on from that, the next thing we might want to do is to use some data science algorithms to identify customers that are similar. And here we can do that by projecting a graph of a customer and their associated emails, phones, and identifiers, and running an algorithm called weakly connected components that will group customers together that are similar based upon their relationships. And when we run that algorithm, we can see here that we've created these little mini communities of customers, which are yellow, as well as some PII or identifying information that they're sharing. We can then further refine this process by assigning some weights to the features. Maybe we weight the customer ID more highly than we do a phone number or an email address, for example. And then we can use those weights to run another algorithm called node similarity, which takes into account the weights of those relationships and then finds or actually creates an embedding that tells us which nodes are similar. Much like a vector embedding that we're used to using for AI, these node embeddings are capturing the similarity in that embedding. And then we can do look at those and identify which customers cluster together based upon those similarities. So here is an example. We found a group of customers that are sharing a lot of same or similar information, telling us that these might in fact really be the same customer and not multiple customers as we have represented in our data. And we can even further refine that by only looking at the highly weighted matches and taking that to the next step, now starting to compare names. So if we have John, which is John, and Jon and Johny, those might really be the same customer. So we can use some algorithms for name similarity. And ultimately what we can get to is identifying customers that we've recorded more than once that are likely to be the same customer. And here we could see the groupings of those customers. Here's an example where we have 4 customers and their associated PII. Once we've done that and we've resolved our customers down to a single unique record, we can now take it to the next step and do segmentation. Segmentation is where we look at some characteristics of a customer. I'm going to suggest that we use the products that they've purchased, their purchase history, and try to group customers together based upon similarity. And so here, what we're going to do is a fast random projection, which is a data science technique, where we're going to project that graph based upon those purchase relationships with products, and then use that projection to identify what are the most similar customers to this customer. And we can now group those customers together. And we're using an algorithm here called k-nearest neighbors to do that. Once we do that, we can then create communities based upon the similarity. So group similar customers with similar behavior with respects to products together. Here you can see we've done that. We've created a number of communities. You can see the sizes of those communities here, and we can also visualize them. So here's an example where we have a group of customers identified in yellow. We call this a segment of our customer base, as well as the products that they purchased and interacted with in violet. So the graphs in this case are helping us to group customers together so that we can offer them products that they're likely to buy. The final technique that I want to show you briefly is called churn prediction. So here what we can do is we can use the graph that we've created to identify customers that are likely to churn. And one way we might do that is just very simply looking at customers who've returned a significant percentage of their orders. And here's a query that would show that we see a customer and their string of orders as well as returns. I think the orders here are in violet, the returns are in orange. So you can see here that here's one individual customer and we follow their chain of orders and we can determine, hey, they've returned a lot of their orders. And we can even get more sophisticated by looking at the time aspect of those returns. So perhaps we want to look at customers who've returned a lot of orders recently. That gives us a signal that this customer is starting to become unhappy because all of a sudden they've started returning their orders. And here we could see a similar graph which shows, the history of orders for a customer, and we could see when the returns start jumping in. And so we've seen in this quick demonstration 3 techniques for improving our customer experience: entity resolution, customer segmentation, and churn prediction. And we've seen how graphs and graph algorithms can help us very, very quickly improve our customer experience using those techniques.